So now I'm going to substitute in what I know. So c squared is what I'm going to be finding, is equal to a squared. So that's going to be 16 squared plus b squared, which is 10 squared, minus 2 times my a, which is 16, my b, which is 10, and cosine of 42 degrees. Okay, and then I'm going to be putting that into my calculator. And since I want c, well, really x, but I'm having c be my x, not c squared, I'm going to take the square root. So I am going to take the square root of this side, which would give me c, and then I'm going to take the square root of this side. And so when I put that into my calculator, second square, oops, second squared, and then I'm going to do 16 squared plus 10 squared minus 2 times 16 times 10 times cosine of 42. Put all of that in my calculator, and I get a 10.87. So I get a 10.87. That is my little c. Okay. The next one looks like it's a right triangle, and you can't just assume because it looks like it, but they drew that in. So this one is our old right triangle trig that we did in integrated 2. Okay. So I'm going to be thinking of SOHCAHTOA. Okay, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So I know my 56. This is going to be opposite of my 56, and this is going to be my hypotenuse. So opposite and hypotenuse is sine. So I'm going to go sine of 56 is equal to x over 9. 9 sine of 56 is equal to x, and I'm going to put that into my calculator. So 9 sine of 56, and I end up with a 7.46. 7.46 is our x. Okay, on this one, we want to solve for x. Okay, and we want to kind of pay attention to what we have here. And so let me just label these. Let's say that I consider that a, so that means that this would be my little a. And let's say that this is b here, then that means this x that I'm trying to find, that's going to be my little b. So that's what I'm going to be finding as my little b. Okay. And then this angle here, let's say is C, so this side is going to be C. Okay, so again, angle opposite side, angle opposite side, angle opposite side. Now I know a pair, so if you know a pair and we're trying to find the side, if you know a pair, you're probably going to use law of sines. And you might say, well, that's great, but I don't have this side and I don't have the angle opposite it. But if I have these two and I know two angles, I can always find the third. So I can easily find the third side by going 180 minus 120. So 180 minus 120 minus 51, and I get 9. Okay, so this one here is going to be 9. Okay, so this is going to be 9 degrees. Okay, so now I've got these ones in purple. I know this one here in blue, and I'm trying to find this, so I'm going to use law of sines. Now, you need to look and see, was it side-side angle? It was not side-side angle, it was angle angle side. So I don't have an ambiguous case, only if it's side angle. So I'm going to do sine of 120 over 25 is equal to sine of 9 over b, cross multiply, so I get b sine 120 equals 25 sine 9, divide both sides by sine 120. So little b, which is our x that we're trying to find, is 25 sine 9 over sine 120. And I'm going to put that in my calculator. And so when I put that in my calculator, I get, and I'm going to do alpha y equal for this, okay? Get my fraction. So I end up getting 25 sine 9 over sine 120. And I get a 4.52. So 4.52, and that's your answer for B, which is our X, right? That was our X. Okay. Next one. So this one I'm solving for X, it's right here. And this one is going to be law of sines. Again, let's kind of match things up. I know this angle and I know the side opposite it. So that means I'm going to be using law of sines. I'm trying to find this angle and I know this side opposite it. Now, this is side angle. Side angle. So that means that we have an ambiguous case. So I'm going to find this value, and then I'm going to see if it's possible to have another value for this. So I'm going to do sine of 41 over 17 equals sine, let's say x over 15. And I'm going to cross multiply and solve. And so when I do, I get 15 sine 41 is equal to 17 sine x. I'm going to divide both sides by 17, okay? And so I get 15 sine 41 over 17 equals sine x. And if I want x, which is an angle, I'm going to do sine inverse. So I'm going to get x is equal to sine inverse of this whole thing, 15 sine 41. Whoops, that's a 15, not, forgot my 5. 15 sine 41 over 17. Okay, I put that in my calculator. Just make sure we can see that. Okay, so when I put this in my calculator, so sine inverse alpha y equal 15 sine 41 over 17. I end up with 35.37. So x is 35.37 degrees. Now, again, since it was side angle, it could be in one that has an ambiguous case. So let me see about the other angle. So x could possibly be 180 minus the 35.37. And so when I do 180 minus 35.37, I end up getting 144.63. 144.63. That's a 44. Now, what I need to check and make sure is that this triangle is possible. So can I add the other angle I know, which is 41, and am I going to get something less than 180? No. So not possible, the second triangle. Okay. So this one was a no. Okay, again, because when I take 180 minus this angle to find the other possibility, I need to make sure that I don't get something that's too big, that when I add it to 41, I'm already beyond 180. Okay, so this is your only answer right here. And let's see, next one. Yep, that's the end of this one. Okay. Tomorrow we will take notes on this. I will post up some notes, but tomorrow we will write them down officially.